Hello and welcome to the module KF5004 Advanced Operating Systems. This is session number 1, which is the module introduction. My name is Neil Elliott. What we're going to look at in this session is exactly how the module is delivered and what its content is. So predominantly it's advanced operating systems, but what we're actually going to be looking at are services that are deployed within operating systems. So instead of looking at the desktop operating systems, we're going to look at servers and the services that run on them. When we've done all of that, we've got an assessment to look at, and that assessment is going to be an assignment that comes in around about week 8. But what I also need to talk about in this session are some of the lab resources we have, how we're actually going to deliver this module. We're going to be doing quite a bit of practical work, so we need quite a few resources, and we need to be able to work inside and outside the laboratory, because by doing, you learn. So to do that, we're going to use virtual machines. So in this introduction, I'm going to do a little breakdown of what virtualization is, and then how it's used in the module as well. So just a quick recap there. We need to know what the module's about, how we're going to assess it, what the resources are, and how we're actually going to be able to deliver this kind of module, given that we need so many resources. Okay then. First of all, the module is advanced operating systems, as I'd said, but what we want to look at is networked operating systems, and specifically the server technologies. We're looking at the architecture that is required to deliver other services. So although we're going to be building a web service in here and integrating other services to develop that platform, what we're really focusing on here is how services interoperate. So we're going to be looking at domain name services, and we're going to look at how that is integrated to our network to allow us to run web services effectively. What we're also going to look at is how we can use networked file systems with the web services to provide us with some distribution so we can create scalable systems. And we're also going to look at how we can put in database systems to link the web systems in and give us a dynamic architecture. And what we're also going to do is have a little look at authentication mechanisms using DNS as an authentication infrastructure for NFS. So we're looking at how services can be deployed to give us a corporate architecture or infrastructure for delivering many services. As I say, this module, we're a little bit restricted. We haven't got an infinite amount of time. So we're going to have to narrow it down. And that narrowing means we're going to just look at 4 key services. Now, when we build all of these services, one of the things we really need to do is practice. By working with these networked operating systems and then playing with the services, what we're able to do is develop a better understanding. So the way the module works is we're going to use a business case once we get through some of the theoretical work and the minor parts of the practical work, as in how to get this installed and run it. When it starts getting towards the more complicated deployment, the business case will actually come into its own. And what we're going to do is we're going to use that in the final workshops as a way of allowing you to investigate how they work. So it's going to cover things like getting the installation of the services up and running and configuring them. So the workshops are very much about how you build it. But that will actually allow you to develop that deeper understanding of what the services provide. The other thing we're going to do is we're going to have within that environment, the workshop environment, so you're going to also have the opportunity to demonstrate how things are working and look at things like network captures. So when different services talk to each other, you're able to see how they operate. What we're also going to then do is, given that you've done so much work on that business case study, we're going to use it as the underpinning component of your assignment. So the assignment is going to be very much about how you've understood the services, how they work, how they're delivered, how they're configured, and you're actually going to use components of the case study to do that. So you'll use components of the case study in the assignment to say, this is how this was done and why. So it's all around the business case, the practical work, the feedback that you get as you work through that, which then allows you to complete the assignment within the actual module. Now, one of the things I've said there is we're using server operating systems, and I used it in plural, and that's because we need quite a few of them. We don't just have one machine running all the services. It is possible, but you're not going to be very scalable. You won't be able to manage many users. And the whole idea of what we're looking at in here isn't the small, we're looking at the large. So to do that, we need a lot of machines, and there's not enough machines in the laboratory. Each one of these business cases takes at least 10 servers to build. So it's not going to be easy to provide, say, 80 students with 800 servers in the laboratory. Likewise, we can't expect you to have 10, 15 servers sat in your own workspace somewhere. So we've got to think about how we're actually going to deliver this. What we need you to be able to do is have that kind of environment, not physically, but virtually, so that as you build it, you can develop expertise and you'll understand and experience the process of deployment, which is a big thing. As you do the deployment and things don't work, you fix them, and then you get a better understanding of how they work. So what we want to do is have the ability for you to be able to work on your own project, as working on the business case, but also be able to have the flexibility to move that wherever you want. On top of that, we also want you to work as far as possible in groups. Share your knowledge with each other. If you build something and it works, share it with somebody so they can actually use it and learn from it as well. Or actually work collaboratively to build a single solution. So instead of having just each individual person having their own business case built, share your resources. Work together in groups. You can do that with the machines because you can share them, and because of the way we're going to deploy them, they'll actually be visible on the network. So from 2 different desks, you'll all be able to see each other's machines. So you're very much encouraged to help each other and to work together, especially with the helping others. If people don't quite understand something, one of the things that you'll find very useful is helping them. And the reason for that is they're going to learn from what you understand, but as you show them, it will reinforce what you've learned. And sometimes you can actually see somebody's different approach to how they were attempting something that may be better than the approach you took. So this collaborative sort of way of building solutions and working together in groups helps in both directions. You as the person helping somebody and the person being helped as well. So I definitely encourage that. But again, we don't have enough machines to physically do all this, which is where this virtualization is going to start coming in. Now, when it comes to actually doing our deployments and needing all these servers, there could be many different kinds or types of servers we could use. We could go down the route of using Windows Server 2016. We could go down the route of like the Linux route, using things like Fedora, Knoppix, Ubuntu, Red Hat, etc. Or we could even go completely off to the side and use something like OS X. So we have to pick something. So what we've done in this module is we've picked something that's got a lot of popularity and a lot of support in industry. So we're going to use Ubuntu. We're going to use Ubuntu Server and the long-term support version, which we'll come on to. The long-term support version means that based on the version we're currently using, which is 2004 for this module, there'll be more on that later, we know that there is a 5-year life cycle on that. So that takes us to 2025. So hopefully when you graduate, having done this module, it will still be out there live in the field. So as I said, this module is going to be very much based around Ubuntu Server for the service deployment. We will need some client software as well, and that's to interact with it, but the main core of what you're going to be building is going to be done in Ubuntu Server. That brings me on to the lab resources and virtual machines. And what we have to do is we have to be careful in how we actually run, or which virtualization environment we run. In the laboratory we have, in the labs on the 2nd floor, we have 3 laboratories, all off-campus and all running virtualization environments. They run VMware on the Windows partition because the machines are dual boot. There's a Windows section. We can also boot to Linux, and on Linux we've got VirtualBox. Now the reason we segregate these is because they don't play very nicely when they're put together on Windows. The way the network drivers are written, they can cause problems if they're run together. So a couple of issues there. One is, please never install VirtualBox on the Windows partition. And 2, try not to use the VirtualBox VirtualBox on the Linux component because that is specifically there for other modules, for other uses. And the other problem you have is VirtualBox leaves a fingerprint when you create VMs, and they're not very easily transported. And what we need is the ability to give you as much portability as possible so you can take your virtual machines anywhere. You can work from home or any machine in the laboratories. And VMware is better at doing that for us than VirtualBox. VirtualBox can be ran in a certain configuration that allows it to work, but it's needed in the very specific configuration, which is why it's on the Linux partition and we shouldn't interfere with it. So, the virtual environment we should use is in Windows. But what is a virtual environment? If you haven't used a virtual environment and created virtual machines, they're a bit of a mystery. But they're not really that complicated. They're complicated, but they're not that complicated to actually understand what they're doing. What we need to do, just to sort of give us that overview of the virtual machines, the environments and what they're for, is we need a better understanding of the different types of virtual environments they are, and then what the advantages and disadvantages of those are for us. Not that it's a part of any kind of the assessment, but it just gives us a better understanding of what we're doing and why we're doing it. It's always nice to know why we're doing things. The next thing is we're going to look at why we use the VMs, because of what it gives us on a local machine in virtualization rather than containers. We're also going to look at the issues that virtual machines have, because once you've worked with them in this module as a teaching environment, you may think that it automatically translates into industrial deployments, but there are issues you need to be aware of. Yes, it's very good, that can be done, but don't let this module sort of lead you to believe that VMs are going to solve all of the hardware problems that could possibly be out there. They won't. There's a place for them. What I then want to do is talk a little bit about the lab setup and how it's set up specifically for the VM running, and then how we're going to use those VMs, what we're going to do with them and how we're going to have them deployed, what they'll do for us really. So, first of all, what is a virtual machine? Well, a virtual machine is a software implementation of hardware, or a machine, a physical machine. Be it a machine that you have on your floor, your sort of like your tower machines or your laptops, etc. It's basically software, a software implementation of that hardware. So what you've got is software that emulates hard drives, network cards, microprocessors, graphics cards, etc. And even things like USB ports. We'll come on to that in a moment. So they basically emulate hardware. So that's the purpose of a virtual machine. A virtual machine environment. A virtual machine and what it's doing. So the virtual machine is actually all driven by software. So what we do is we're running an operating system, which is software, inside another piece of software, which has its issues. There are two types of hardware emulation that we have. The one I've just described is type 2, where you have a software virtualization environment and then you run your software inside of it. But it can also be type 1, which is hardware emulation. And in effect, the hardware is split. So these two are very different. So what we need to be thinking about is, when we have hardware, it can be split. Some environments provide that with hypervisors. Some, what they will do is they will provide virtualization, but at a software layer. So in effect, what we're doing is we want to take our software operating system and run it in one of those environments. But the one we're going to use is the software-based. In effect, the reason we're doing it is in a hypervisor type environment, the hypervisor emulates very specific devices. There's a management component which manages all the hypervisor and what's going on, and then the operating systems run directly on top of the hypervisor. And the hypervisor is hardware implemented. So you are limited to what the hypervisor can emulate. With a virtual PC environment, what you actually have is a host operating system. In our case, we're going to be using Windows, and there are interface drivers that a guest operating system communicates through. So you can change these virtual drivers as and when are required. So you tend to find that in this the virtual PC environment, there's a lot more support for a lot more operating systems and hardware. So that's the route we're going to go down. So the type 2 environments, now that we decide we're going to go down it, there are many. We are going to use VMware, but we also have things like VirtualBox. If you're working in your own platform and environment and you're not going to be using the resources in the university or the laboratories, or you're going to use those resources for network access to the internet, but you're going to run everything on your own machine and you're not going to be sharing it, if you want to run VirtualBox, you can do everything in this module. This module is not about virtualization at all. It's just a tool we use to deliver the module. We've got other virtualization environments that are type 2, things like Microsoft Virtual PC, although that's quite old now. Things like Parallels, VMware, as we've already mentioned, but we've got Zen and KVM, etc. And they're all very good environments which work for different purposes. For instance, I use a product called Proxmox, and I also use headless VirtualBox as well in certain instances, because they fit my need. The need we have for delivering this module is something quite different, so we use VMware on the grounds it gives us that one advantage that we really need, which is portability and transferability. Because the VMware machines that you create will run in the Linux version of VMware and the Windows version of VMware, and they're very easily transported from one machine to another. So it works exactly as we want to give us maximum flexibility in this module. Now, some of the advantages of why VMs are a good idea, and that's not just inside this module but outside of it as well, are basically if we have expensive hardware and we're only using about 20% of its capability, it's wasteful. However, what we can do is make efficient use of that hardware by running multiple machines on it and still keeping everything separated. We still have that independence of sandboxed environments, but we use more of the hardware's capability. The nice thing about the sandboxed environments is if something gets malware on it or crashes, or for some reason the bootloaders, etc., corrupt, you don't lose the entire infrastructure, you just lose that one component. So you can rebuild it, so recovery is much easier. So one of the other reasons that virtualization works well is because even if you're putting it onto a single machine and you put multiple services onto it, you're actually giving a slight a level of protection of each individual service as it runs. So it's another reason to actually use virtualization to keep those services separated. As I said, for this module, the big thing for us, we're using the VMs because they give us some independence from the laboratory. You can work away by basically having your virtual machines on a USB drive. And before I go on any further, a good idea to use USB hard drives, not USB sticks, because they're a little bit too slow. The hard drives are better, and SSD is even better. So they give us that portability and the speed and the independence from the lab, so we can move around. Again, that is actually best achieved by using VMware, because it gives us that image, that isolated image in an individual folder. The other reason it's quite useful is because VMware, we have it licensed to run in the lab, but for yourselves running it on your own machines and at home, it's free for non-commercial use. So you can run the VMware player no problem. Now, what are the issues with VMware? Well, the issues we have is they take a lot of resource because the base operating system has to run as well as the VMs. So although we get this extra utilization of the hardware, we actually have overheads. So we need to be aware of that. Likewise, virtualization, the machines will always run slower because of the software emulation. The software you're running is used to running on hardware. However, the hardware is now software, so everything has to be reinterpreted and passed down to the hardware layer. So there's these layers of translation that are going to slow everything down. The other thing that we have an added issue with is to use VMs, we actually have a virtualization environment that we now have to manage, as well as the operating systems that run the services. So there is a management overhead as well. The other thing we need to be aware of is some hardware, when it is in an emulated environment, can't be shared. And we're going to find that when we actually start plugging in USB drives to machines that are running multiple servers, because it's going to ask us which server do you want to attach this hardware to. So there are limitations. In our case, we wouldn't be attaching our USB drives to any of the virtual machines. We just attach it to the host machine because that's where we're going to start running them from and backing files up. But just to be aware that there are limitations with emulation when it comes to shared resources as well. Okay, that said, using a USB drive is the best way to store all these virtual machines for portability. So one of the things you will need to do is have some kind of storage outside of your machine. If you're running everything in your machine and you're not going to share it and transport it anywhere, that's fine. If you're actually going to be going between locations and sharing the work you're doing, you will need to do this by using a USB hard drive. When you get your drive, because you can sign them out from the university, the best thing to do is create yourself a couple of folders. Make sure it's formatted in NTFS format. There's reasons for that, which we'll cover next week. But make sure it's formatted in NTFS. Create a couple of folders. Put your ISO files or installable disk images in one folder. And when you create any virtual machines, put them in the other folder. Then, wherever you go, you've got all of your machines plus the ability to reinstall them. What I would then suggest is you treat that USB storage very carefully and keep it with you at all times, on the grounds that when you're working on your own at home or working in the laboratories or working somewhere else in groups, wherever you're working, the issue you will have is you're always going to need the VMs because of how practical this module is. But also, all of the laboratory sessions in this module will require VMs to be running. Now, to try and expedite things in the module, one of the things I've done is I've created some basic server images for you. I've also created a very basic client image as well, but we'll come on to that in a minute. The idea by me creating that pre-installed image is it allows you to very quickly create or duplicate server machines so you can build. So when you're actually in the module, if you need more machines, you can rapidly create them. If you fall behind in any of the work for whatever reason, or you corrupt an image, you can very quickly recreate an image from the pre-created images I've given you. And they're located in a couple of places. One of them is actually on the NAS drive in the laboratory, and from the Windows prompt, if you go to nas3offcompassnetwork.co.uk, you can find the modules folder for this module, and inside there are copies of the VMware images, but there are also some OVA images of the machines as well, which I'll come on to. Now, these basic images are fine for you to use, but you should be comfortable installing operating systems on your own, and the best opportunity to do that is at the beginning of this module. Get that out the way, be comfortable with it, and if ever you're stuck and don't have access to the base images, you can still create your own images as and when required. And I would suggest that you look for them not just on the NAS drive, where I've told you, but also look at getting them from the supplier, from the ubuntu.com website as well. As I've said, this module is all based around Ubuntu server, but you will need a client that you will configure to link to it, because we won't change any of the base machines. We don't need to. Once we're running virtualized, we can run a virtualized client and link that to the system, so your base environments don't need to be reconfigured at all. So, the next thing we need to know is, if we're not in the lab, what do we do? Well, if we're not in the lab and you have access to Blackboard, there is a folder called OS Image Downloads, and in there is information to tell you how to get it from the lab, but also how to get it from a Dropbox account which is set up for the university, where you can grab the images from there. The OVA images are deliberately on both the NAS drive and this Dropbox image as well, for the simple reason that OVA is transportable. So if you're using VMware, you can import the images and you can work in the laboratory. If you're working on your own isolated machines and you want to use VirtualBox, you can use the OVA images there as well. So by using OVA images, you're in a position to use whatever environment you want. However, remember, we're encouraging you to use VMware. It's just if you're comfortable working on your own machine in a different environment, it will still work. But bear in mind, we won't support that environment for you. There is also an addendum to this session 1, which covers the OVA files, VMware, and the importing and exporting of your images and how to work with them. So I would definitely suggest you give that a watch. So finally, what you will need to do to get yourself up and running for this module, if you haven't got your own storage, I would strongly suggest you sign out one of the university USB drives. In fact, even if you have your own storage, I would still suggest that you signed out one of the university's USB drives, on the grounds that if there is any problems or issues with it, they will resolve it for you. Even if the drive fails, they will supply you with another one. So it's always useful. The other thing is, when you get the drive, make sure you check the format. It needs to be NTFS. More on that later in the module, but make sure you do that up front. The workshop for this week is for you to familiarize yourself with VMware. So if you're going to be working in the lab, that's fine. If you're going to be working at home, download it and install it. But the idea is get yourself comfortable with that, whatever environment you're going to be using. Hopefully, the majority of you will be using VMware. To do that, though, you're going to have to do a little bit of research if you've never used it before, and that's where being second-year BSc student comes in. By now, you should be starting to be a little bit more independent when it comes to technology and using technology. So we're not going to go through the installation of VMware or anything like that. However, we do talk a little bit about some of the gotchas that you're going to need to look out for as we go through the module, just to make sure that things run successfully for you. But we only do that with VMware. But being second year students, this is the kind of thing that you should be resolving yourselves by now. Okay, and that's all there is for this session. So basically what we've covered is what the module is about: network services, how they work, how they're deployed. We've also discussed how we're going to run them within virtualization. We've discussed the fact that the assessment is going to be an assignment, and we're using a case study to do that. The resources we've got, we're aware of what's in the labs and how we should and shouldn't change things, and we also now know why we're going to use virtualization. So the first thing we need to do is start playing with those environments, and to do that, that's what you've got the workshop for. So you've got workshop 1, which basically is setting up or configuring a virtual machine, specifically an Ubuntu client machine, which you'll then use throughout the rest of the module for linking in to the actual infrastructure as you build it. Okay, I'll see you in the workshop.